好，大家好啊，大家好，对，哈哈，哎呀，今天非常高兴啊，这个请到了除我之外啊，应该是3位都是真正的专家啊，我简单每个人先介绍，然后等他们自己介绍啊。这个今天呢，我们知道为什么要搞这么一个直播呢？是大家可能应该关注大模型的人应该都知道这本书哈，就是封面是这个袋鼠啊。就是我们翻译成图解大模型，英文呢叫 hands-on 啊，LLM。这本书呢为什么有名呢？是因为这书的2位作者，一个是 Jay Alammar 是吧？另外一个是 Maarten Grootendorst，这个名字很长啊，这个 long given name。Jay 呢是非常有名我相信学大模型可能都知道，就是最开始大模型，因为大家知道有个核心的叫 transformer 是吧？transformer 其实还挺复杂的这个技术，但是你只要无论是当时还是现在，你在百度啊或者 Google 搜 transformer，应该首屏前几条一定会有一个文章或者说它的中文版是吧？翻译叫 illustrated transformer illustrated transformer 这个文章的作者就是 J 啊，所以呢。我相信也是 Already 的编辑啊，看到国外那个出版社看到这篇文章非常受欢迎，然后找到了 J，当然 J 呢可能又找到了这个 Maarten 是吧？2个人合作，当然等下我可能要问他们啊，他们这个书怎么来的？这是作者啊，2位作者是我觉得是在全球吧，这个解释大模型这件事情上，可能是最擅长的人啊，因为他们用几百张图把这么复杂的技术讲的，我觉得基本上你没有技术背景，其实翻一翻很多事情也搞明白啊。然后呢，我们的译者也请的非常给力啊，李博杰啊，李博杰呢，博杰他其实非常年轻但是呢，他又年轻又资深啊。博杰应该是92年出生的，对吧？
对，我是92。
92年为什么他又资深呢？因为他是中科大少年班的啊，大家懂是吧？就很岁数很小就上了大学，然后呢就带着天才的标签了。而且他呢工作以后呢又加了一个天才的标签，就是华为的天才少年，对吧？这个大家也知道，在国内应该华为天才少年这个 title，因为大家知道都是你在学校里头应该非常非常出色的，才能进入华为的这个这个圈子里头啊。然后现在呢，他又自己在创业啊，搞 agent 啊，所以我们今天3位嘉宾非常的这个重量级啊。然后呢，我们也给时间啊，给几位嘉宾每个人介绍一下。Jay，please introduce yourself.
Incredible. Excited to be here with all of you. So yes, I'm Jay Alammar. I'm a machine learning researcher. Over the last maybe 9 years, I've been writing a very popular blog. As you mentioned, the Illustrated Transformer. It's been read by millions of people. And in this blog, I've been catching up and explaining to people the latest developments in NLP over the last 10 years. So before transformers, there were things like deep neural networks, encoder decoder models, then the transformer, and then the various applications of the transformers, BERT models, using them in search, and then more and more advanced. So we talked about the DeepSeek recently and the reasoning LLMs. And so most people have come across my work from the blog, and I also go around and speak and give talks and create educational videos on YouTube in addition to the writing. But the best work I've done so far is the work we're talking about here today. It's my collaboration with Maarten creating this incredible book. We're happy to share with everybody, and we're grateful for touring and everybody here in getting it to the Chinese speaking audience.
伯杰可以简单翻译一下啊，因为今天伯杰还有一个重要的任务是翻译。
对，这个我实际上非常荣幸能跟这一块这个合作来把这个翻译这本书。这个因为这刚才说了，就是说这 Illustrated Transformer 是一篇非常有名的9年前的博客文章。然后它是这个当年是上百万人，其实我自己都是从这篇文章才学会。
已经9年了啊。
对，然后当时
9
其
years，
实
哇，
那就是 Transformer 那文章刚出来的时候，然后当时我都看不懂，然后不知道是啥，然后当时有一篇 Illustrated Transformer， 然后我可以然后我就学，然后就终于说啊看懂了它的一些 attention， 然后等等是什么意思。 然后包括说最近这本书里面又加入了一些新的内容，比如说像 DeepSeek R1的一些，就是说现在比较火嘛，然后还有一些很多各方面的一些这个就是说最新的一些知识，相当于他把这篇文章然后扩展成这本书的第3章，然后其他的章节呢又是一些跟我们整个的这个书非常相关的，而且呢我觉得就是说甚至是加一点私货啊，就是说我觉得这本书里很关键的一点就是它不只是有这个生成式的模型，就是 generative models，同时的话它还有这个 classification 这种，就是相当于是这种representation models， 就表示模型，它就如果说一个知识，然后如何把它变成一个 vector representation of the knowledge 啊，那这个东西呢，其实也是在很多场景下大家所忽视的，但是也是非常重要的。我觉得这个也是这本书很大的一个特色。然后当然这本书里边还有这个好几百个很好的这个 figure， 然后这个可能就要这个刘老师来 introduce Maarten。
Okay, now it's your time, Maarten. Please introduce yourself firstly.
Thank you. I'm incredibly happy to be here, very excited for the launch of this book. My name is Maarten Grootendorst, and I'm actually a psychologist before I went into all of this AI craze. And as a psychologist, I started thinking about, okay, how can we make all of this very complex techniques within AI, within deep learning, accessible to a larger community? And as a result of that, I started dabbling into creating blog posts, educational content, to eventually create open source software that I believed was used in a way that makes it easier to approach these kinds of techniques. So I'm the author of open source packages like Per Topic and Keybird and Polyfos that really focus around extracting information from potentially millions of documents. And through all of that educational content, I started exploring more and more this field of large language models. And especially the last couple of years in collaboration with Jay, focusing on visual guides, whether it's topics like mixture of experts that are now heavily used, quantization, multimodal techniques, agents, reasoning models. It's just a blast to focus on getting all of this complex field, this complex technique to as many people as possible in a way that makes it fun to focus on all of this content, that makes it interesting to read about this instead of, quickly being scared away by unneedingly complex mathematical formulas. When it comes to education, can be quite intuitive. Eventually, this book is a highlight of Jay and I. We are very happy to introduce this, especially now with updated content compared to the original version.
刚才 Maarten 呢是他之前是个心理学家，然后但是他实际上是一个好几个开源的很有名的库的作者，然后他之间利用了很多的这种 machine learning 的技术，然后来应用到他所在的这个领域。然后呢，同时的话，这个 Maarten 呢，就是他跟 Jay 合作写的这本书，它的特点就是说他没有用很多的这个数学公式，而是说呢，他用了很浅显的这样的一些文字和这个非常直观的这些图画。然后因为 Maarten 特别擅长画图，所以说呢，他把这些把这个 LLM 这样的一个很 complicated 很复杂的一个 topic， 然后把它介绍给大家，让大家能够即使没有什么技术背景，然后也能够轻松的学会大模型的这样的一些基础知识。
对，我突然想起来啊，就是那个有一个问题，也在追问一下3位，就是我其实注意到，比如说 Maarten 其实原来不是搞计算机的，是吧？然后博杰你之前你是搞那个，你当然计算机科班的啊，读到博士，你是搞什么方向的？
I was doing networking research and also AI infrastructure research. I was doing this kind of research in Microsoft Research Asia because, for example, there's a very big cloud. We have 1 million of machines. So how can they interconnect together to form a very highly efficient systems to do the machine learning, the training, inference, and other kind of tasks? For example, the ranking, the search engine, and also the kind of, for example, virtual network functions that enable the firewalls, the kind of load balancers, so on and so forth.
对，所以你是 AI infra 是吧？了解 AI infra， 但是现在博杰是转了就是 AI agent 了，是吧
？Now I'm doing AI agents.
Maarten 的跨度很大 ，Maarten 一个you move from psychology into deep learning and data science, right? Hey,
Yeah,
Jay, what's your major in university? Jay.
In computer science. So yeah, I've been
So
doing
you
writing
are
software.
native. So you have a long time deep learning background, right?
Deep learning only maybe about 10 years, but lots of software development before that. Yeah.
Yeah, I know. 对，我还忘记介绍我自己了啊，我是今天的主持人啊，然后也是这个图灵的联合创始人。当然，我跟大模型这个渊源呢也很久了哈，因为我2018年呢是参与创办了北京的智研人工智能研究院啊。如果熟悉中国大模型历史的，应该知道这个智研研究院呢是中国最早搞大模型的一个机构。所以我们是2020年在 GPT-3这个论文出来以后，然后整个全院基本上把重心都放在这个大模型上。然后我在那个之后呢，23年我还参与了这个大模型独角兽光年之外的创业。然后呢，最近呢我还在这个智谱，就另外一家大模型的独角兽，还做过这个高管。所以呢，我也老自称自己是大模型专家，当然我不是技术专家。所以今天呢，重要的技术还是需要，这本书的3位作译者啊。那我们接下来就进入我们的这个问题环节啊。刚才是一个热身啊 ，warm up time。第一个问题呢，就是也还是啊，就是大模型实际上是现在比较核心的一个知识啊，就是已经很重要的技术了。但是呢，想问一下大家，就是3位这个专家，你自己平时啊是怎么学习大模型？因为我们也知道大模型现在技术方向非常多，而且迭代很快，是吧？然后你们是怎么学的？然后怎么能跟上这个迅速的变化？好吧，先是这么一个问题。
The question is that the field of large language models is evolving very fast, like a fast wave. So how can we catch up with this kind of wave, and also how ourselves learn large language models? So Jay, could you go first?
So it's definitely the field moves super quickly, and it's difficult for everybody to catch up with everything that comes because every couple of weeks there's some major development that changes everything, and a lot of very small developments that could be big in the future that you really don't know. And one interesting thing to note is that when I first wrote the illustrated transformer, the transformer was not a very big development then. It was a paper on machine translation only. It wasn't this major NLP thing that changed everything. And so reading lots of papers, following people that explain and write and sort of blog or write on social media about the big important things, that's the only way to do it, is for all of us to help each other out and sort of identify the big themes and our major takeaways from papers that we read as well. That's all. We can all process it as humans connected as a one supercomputer together.
I'm Maarten.
Yeah, so the thing is, and as Jay mentioned, this field moves so incredibly fast that just keeping up with everything is near impossible, right? We can try, but we will never get there. And Jay and I ourselves, we also the same way have trouble catching up with everything that's going on out there. But I think a good tip would be to just focus on the things that are interesting to you. It might sound like very simple advice here, but it truly helps, because are you going to focus on mix of experts and different types of attention matrices? What about reasoning, reinforcement learning, supervised fine-tuning? I can go on and on and on. But they all have things that relate to one another. So if you dive into one thing that's interesting to you, you will be exposed to all other things. So make it fun for yourself. And truly, that's the best way to learn.
刚才 Martin 说的我觉得特别好，就是说它可以把这个，就是虽然说是发展的特别快，但是说呢，它总有一些关键的一些点，然后我是真正感兴趣的。比如说我对这个 IL 就是强化学习感兴趣，或者说我对 MOE Mixture of Experts 感兴趣，或者说对其他的感兴趣，那么我就 focus 在我的这个每一个阶段有一个方向，然后它就可以 catch up 起来。然后包括刚才 Jay 也是说的，我不停的去读这些最新的一些 paper。And in my opinion, I think that the answer lies in the name of this book, the hands-on large language models. We need to be very hands-on. We need to try and use a lot of large language models. For example, from OpenAI, from Anthropic, from Google, from all these vendors on the SOTA kind of models, and we'll find which model is expert, is better at which kind of task. And for example, some are better at coding, some are better at math, some are better at reasoning, and some are better at agentic tools. Yeah. So this is kind of a very large spectrum. I often consider it as a garden of many kind of models, and each model has its expertise. And we can so to us who are doing AI agents, we are leveraging different kinds of models. Some are faster, some are more intelligent, and to make them work together to be a more intelligent and a cost-effective system.
对，伯杰，你可能还得用中文稍微说两句吧，你自己的。
对对，我刚才说
当然，
了。
我刚才看到我们这个直播的这个是有好像有实时的英文翻译的，好像。
对，好像是有英文翻译的。然后刚才我也介绍一下这个 Martin 说的。然后因为我自己的话，其实就是我更多的就是 hands on，不停的去试最新的这些模型的不同的能力。比如有的擅长写代码，有的擅长数学，有的擅长这个agentic tools，就是使用工具去做 agent 等等。然后有快的模型，然后有慢一点，但是说它的思考深度更深的模型，然后有便宜的，有贵的。我们就是做 agent，就是把它们不同的这个结合起来，完成一个更大的一个事情。
嗯。第二个问题呢，我看啊，就是其实对初学者的，我相信今天这个在线上也有很多，包括我发到我们那个共学营群里，有好多说，哎，这个书有没有什么知识的这个前提啊、前提知识啊、条件？所以这个问题是说什么呢？如果是初学者来讲，学大模型啊，最关键的一步是什么样的？或者是怎么开始？就三位专家有什么建议没有？
So the question is that we see the book here, and so if we start with the book, so what kind of thing we need to start with? So why we just start to write this book? We can talk about a bit of the story, the background behind this book.
Yeah, I can give it a shot. So AI and large language models are changing the world as we know it. AI is eating software, and for the last 20, 30 years, software has been eating every other industry as well. Every company has to be a software company. But now AI is developing super quickly, especially large language models, that so many different people have to adapt and have to learn the concepts very quickly. Now, we as individuals, as we start to read and learn about these topics, sometimes we found it difficult. Like reading the papers is difficult. You need we feel that you need the intuitions explained, the main ideas, the main concepts explained before you're given like a wall of formulas or mathematical notation or lots of code. And so through our blogs and our writing, we had some sense that lots of people need that as well. And need that gentle visual introduction that explains things. And so people have the main concept, and that builds confidence in people that they can go and learn the next step and learn deeper and deeper and deeper. And so our main goal is to make this technology as accessible as possible to the largest audience possible, to help them in their learning and in their careers, because this will definitely change so many careers out there and create so many opportunities for people if they start the right way and they have the right support as they learn and begin their learning journey.
刚才这说的是它这个大模型的发展非常快，但是同时也非常深，就是有很多搜它的这个最新的一些论文，其实很难懂。然后呢，这样的话呢，我们就需要一步一步的，就是从浅入深的去学。而我们现在这本这个图解大模型这本书呢，就是说给它提供了一个这个第一步，然后呢，能够使得比较更大的一个 audience，就是说更多的观众，就是所有的这个对大模型感兴趣的人，即使没有基础，然后我也可以从这儿作为第一步去入门，然后再以此作为台阶呢，我可以去学它下一半就是最感兴趣的子领域再深入。And for Martin, yeah, could you share your background on this book? Yeah.
Yeah, of course. It's like Jay said, what we wanted to do is create a book that makes it accessible to a large group of people. So whether you're a researcher or a student or even a manager, there's always something to find within the book. It gives you a foundational view of how all of these techniques work and an intuition that allows you to explain it to other people. I think that's the main goal of creating something like this, is that you are able to explain how a large language model works to anybody else, to everybody else. And I think that's what we wanted to focus on when creating something like this. So on the one hand, we have a lot of foundational techniques. This is how large language models work. And on top of that, we created a lot of additional content, illustrated and visual guides that go a little bit deeper into next level techniques. How does mixture of experts work? How does quantization in that work? For those that want to do a little bit more. So we believe there's something to find for everyone.
刚才马上也是说的，我们这本书呢，其实是说给大家在这个大模型的里边的每一个子领域都给了一个 fundamental，就是基础性的这样的一个概述的介绍。然后，那么它只要是对这个其中的每一块东西，如果想要更深入理解的话，我可以再去读论文或者读这个领域的专著。但是呢，这本书呢，可以给大家一个全景式的一个更好的一个认识。Yeah, from my viewpoint, actually, I feel that the large language models, yeah, it's very large area, and it is evolving very fast. So I think the most important thing of this book, especially its Chinese translation, is to introduce the fundamentals of the large language models to the largest audience, to make them know how transformers work, what the boundaries of the SOTA large language models, so what the models can do and what models cannot do. So this is very important. And because a lot of people just think that, especially the startup people who are doing the applications, they think that the next large language model is coming, and the large language model is very productive. So it's killing all kinds of optimizations we are doing, all kinds of engineering work. But this is not true. Actually, if we can predict what is the boundary of capabilities of the large language models in the next phase, so we can build our applications even for the next generations of large language models. For example, we know for vision language models, multimodality, or this kind of reasoning going to be kind of at what kind of pace, so we can develop the applications for the future, and we can make sure that our modes, our kind of competitive advantages are surrounded through these unique kind of advantages of our company, instead of just competing with the SOTA large language models. 就是说，我们就是希望，就是说能够，就是说通过这个对基础知识的一些了解，能够让这个我们每个人的竞争优势都建立在这个就是说自己的这个领域，而不是就是说直接跟大模型的发展去竞争，然后让我们所有的东西能够追得上大模型的这个发展的一个速度，然后同时呢，就是在大模型往前走的时候，不至于说我感到恐惧，说它是不是会把我的工作全部都吞没掉，然后导致我所有的优化都没用了。
对，刚才其实这几位专家呀，其实讲的都非常好啊。我呢，因为我不是特别的了解这个大模型的这个技术细节，不是了解非常非常细，但是整个因为我比较偏战略，所以我基本上大方向我会看的比较多一些。我给大家一个建议是什么呢？就是其实你要回过来看啊，因为大模型我们知道是2018年是吧？要说起来是 GPT 是1的那篇论文，2018年的，到现在已经7年了。对吧？如果从那个 transformer 算起的话，那到现在已经10年了，是吧？ ，Transformer 是2015年出来的。
17年
17年是吧？17年，那就是8年，对，8年。那我们回顾一下，就是实际上这8年，你说最大的里程碑式的这个进展到底有哪些？其实也不是太多的，对吧？你要算起来的话，你说 Transformer 是一个，可能 GPT 算一个，然后 BERT 我不知道算不算特别大的，是吧？然后呢，Chat GPT 那个，对吧？就是它加了后训练，就是从预训练到后训练。然后呢，最近的这个推理模型，当然中间还有所谓多模态。其实你要捋出来以后，其实最大的里程碑其实它并不是特别多，对吧？所以为什么就像这个图解大模型我们这样一本书呢？其实打基础非常好，就大家要把这个最基本的这些东西你要知道有这些大的块儿，然后每个大块大概呢，你即使技术不是很强，你也知道，哎，它大概是什么样的，它们之间的差别是什么？是吧？比如我们一般说生成式人工智能，除了 GPT 的这个预训练这个模式，这个 Transformer 这个模式，还有一个架构叫 Diffusion，对吧？就是这个纹身图啊、纹身视频现在用的比较多，然后最近又有一个这个 Flow Matching，就类似这样的模式，对吧？其实这么级别，这个大级别的这个也不是特别多，所以大家先把这些最基本的抓住啊是非常重要的，然后你才能了解，就是说根据刚才伯杰说的很好，你自己要做什么事情，再结合自己的这个专业啊，再去看那个再深入哪些东西搞得更细更深入，嗯。好，那刚才这个问题我们到这儿哈，我们接下来就转到我们书上了啊，就是实际上我其实也很好奇啊，就是Maarten 和 Jay 啊，就是说我当然最前面介绍了这个，我们知道 Jay 是有这么 illustrated 的这个 Transformer 这篇文章啊，但是这本书是怎么来的？就是我们也很好奇背后这个书有什么好玩的故事啊，就最开始。是这个出版社怎么找到这个 Jay 开始要写书，然后 Jay 和 Maarten 又是怎么合作起来的啊？这个问
So,
题我这个翻译一下。
yeah, so the question is that we are very curious. So how you two come together to write this book, and is there any interesting story to share with us?
Yeah, behind story.
Well, yeah. So I've admired Martin's work for a long time, and I've been sort of our conversations with O'Reilly earlier on was like who can be the best sort of co-author on this, and sort of Martin was instantly sort of there as an incredible option, and I'm sort of happy that he sort of agreed to join. And then we've had sort of meetings to plan and outline the book in our style. Sort of when we started working on it, they just worked and complemented each other just absolutely perfectly. It was much better than anybody could have anticipated. But I've known about his work previously, and we've talked online before as well on advanced NLP topics as well. So I've always been impressed with Martin's work, and yeah, this was the beginning of how we started this book.
And it's interesting, right? Because saying as for me is, everybody knows the illustrated Transformers. So when Jay said, I want to write a book and I want to do it with you, obviously that was an honor, and to this day it still is. And now that we're here and we've written the original book and now the launch of this incredible version, we still haven't met, actually. I've seen him from the screen, so I don't know better than he is AI or something. But we haven't actually seen each other face to face. So it's very interesting that we're able to do something as grand, at least to me, like writing such an amazing book, whilst being completely remote, timelines, time zones that aren't remotely close to one another, but still being able to collaborate so well on something like this. So yeah, for me, it's also been an amazing honor working together.
是啊，就是说这两位这个结合起来，真的是非常非常的这个有意思的一个故事。就是说，实际上刚开始认识的时候，还没有想到要一块做这本书，但是只是想着合作写一些文章，对吧？然后再接下来的话，然后又是就是说跨时差、跨时区的大家认识在一起，然后把这本书能够就是 deliver 给大家，对吧？那就这真的是一个很有趣的故事。
I wonder, Jay and Maarten, how you separate to divide the work in this book?
Yeah, that's a great question. Maarten, you wanna take that one?
Yeah, of course. So there were certain topics that felt natural to one person or another. The illustrated transformer obviously had to be in the book as a chapter and everything surrounding it. So it felt natural for Jay to pick up on these more fundamental techniques that relate to the transformer architecture. And then when it comes to things like topic modeling and embeddings, obviously with the BERT topic package that I created, that's something that I felt doing. But then there's still certain topics that weren't necessarily quite clear to do for one person or another. So what we essentially looked out for, okay, what do you find fun to be writing about, to creating new images, new visual styles to do so? And by giving each other the space to focus on the things that we simply enjoy doing and we think is fun, that made it very simple to do this kind of collaboration. So in the most of the things we said, okay, you take charge of a chapter, you're the lead in a chapter, and then the other person is there for additional feedback and to check whether everything flows as intended. Because as we've been writing for many, many years now, we know that we get stuck in our own viewpoints, in our own perspectives quite easily. That's just very, very human to do. So having somebody who is incredible in giving feedback on that specific content helps tremendously. So all in all, quite natural.
Yeah, so just to add a little bit of detail to that, we came up with the outline in the beginning. We agreed on an outline and sort of chapter split and the lead for each chapter. And then each one would write a draft of the chapter and then be reviewed by the other one and sort of evolve them like this. And then after we've had the majority of the book, we were like, okay, maybe it would flow better if we take these 3 chapters in the end, put them in the beginning and sort of, and arrive at this final structure of the book right now, which we find will be very friendly to the different audiences, where part 1 introduces the history and the refreshed illustrated transformer. The illustrated transformer was 7 or 8 years ago. The models have changed since then. And so this is an updated and expanded version in chapter 3 that explains the modern day transformer of 2025. And so that's part 1. And then in part 2, we go into the applications that people use, because most people will not be training their own base model, for example. So they will use an API or they will use an open source model to solve a specific problem. That's part 2. That's chapters from 4 to about 9. And then the advanced users will start fine-tuning, for example, models. And that's the part 3 of the book, chapters 10 to 12. So that's a high level sort of breakdown of the book and how we sort of tackled it from the beginning.
Yeah,
对，我看现在那个进来人很多哈，那个我大概再说一下，这个我们今天的这个呢是应该是大模型领域的技术，应该是一本名著了哈，这个图解大模型啊这本书的一个发布，所以我们非常高兴的请到了这个书的2位原作者啊，一位是 Jay Alammar 啊，然后他现在实际上是在一个大模型独角兽公司搞大模型技术，应该都知道 Cohere 啊 ，Cohere 他因为创始人呢，主要创始人之一是 Transformer 那个作者的八位作者之一啊，是个加拿大的大模型公司，然后也是独角兽啊，所以 Jay 呢现在在 Cohere 这家公司是做这个技术总监啊，另外呢 Maarten 是这个是一位在荷兰的这个数据科学家啊，因为他本身呢原来专业是搞这个心理学的啊，但是大家知道这个国外的很多这个人很厉害是吧？他跨专业能力很强，所以他很早就这个技术能力很强。他其实是有好几个这个大模型领域的一个技术开源项目的这个主要作者啊，所以能力也很强。他们2个是一个强强联合，而且2人呢，一个人在荷兰，一个人这呢是在加拿大啊 ，Canada， 所以呢是这么一个跨大西洋的一个合作啊，也非常神奇。 然后呢，我们今天也请到了这本书的译者李博杰，博杰呢是中科大少年班的啊，然后一直读到博士，然后呢又是华为的天才少年啊，然后所以 AI 方面他是一个大牛，最近呢自己在做创业啊 agent 方面创业。之前你应该是在微软研究院也是实习还是工作是吧？
实习，
是
我联合培养的博士。
联合培养啊，对，你是微软联合，对对对，所以是几个这个很牛的地方的一个这个合在一起啊，就是所以这3位作者都是我觉得是一时之选啊。然后呢，我呢是这个图灵的联合创始人，这个出版公司的代表啊。当然我自己呢也是在大模型领域算是比较早就开始做研究、战略研究啊这么一个背景。所以今天我们非常高兴啊，有这么一个机会，请到3位作者和译者啊来给我们讲一讲大模型现在怎么这个技术应该怎么学、怎么看。当然这本书呢，我们这个大模型这本这个图解大模型这本书啊，我个人是觉得是可能大家无论是你是搞不搞技术人都应该去买一本看一看啊，因为大模型这个时代呢，它有点像什么？我们知道我们现在在这个你只要进入社会，你就需要跟人去打交道，是吧？跟别人除了自己之外，那有一个词叫要洞察人性，是吧？对于你的学习和工作生活都很重要。那所以你要学心理学，是吧？所以现在心理学书很时髦，就大家都要去了解了解我自己是怎么回事，为什么我看世界会这样，还有别人为什么跟我看法不一样，等等等等。但接下来我其实提出了有个概念叫洞察机性，或者叫洞察 AI 性，是吧？就是为什么呢？因为我们现在接下来要进入一个时代，就是人和 AI 要共同协作。进入这么一个时代，所以呢，我们人很可能接下来我们都是领导，我们都是管理者，要管很多 AI。那 AI 到底是一个什么原理？就 AI 的心理学是什么样？你完全不了解的话，你是做不好这个事儿的，是吧？无法进入新的时代。所以新的时代一个重要的这个技能啊，就是要学这个至少大模型的心理学，你要知道。大模型心理学，你就要知道，哎，它的就像。你要了解心理，大概知道人的脑子是什么样的，是吧？神经细胞等等，大概要知道，你才有一些很多现象才会理解，就知道你比如说用大模型产品过程中，哎，怎么会这样，是吧？怎么会那样？它怎么会有幻觉？怎么跟原来的软件不一样？所以你要稍微看一下。那了解这个下面技术呢，非常好的起点就是这本书，因为这本书 Jay 和 Maarten 他们的这个天才之处呢，就是都用大量的图片，有300多张图片，把非常技术的这个内容都演示得很清楚啊。基本上你就看这个架构，这个图大概这么几块，然后这怎么演进，很多很多东西一看就明白了，是吧？包括博杰也说你像以博杰这样的天才少年，最开始学那个 transformer 也是看半天也没看得太懂，是吧？最后是这样的一篇文章，对，就是图解 transformer 对那篇文章，他一看就明白了。所以这本书非常值得推荐啊。我大概介绍一下今天这个背景。哎，我们已经超过了 Jay and Maarten，we have now we have more than 2,000 people watching the live show our live yeah
Wow.
and still increasing 好，那我们接下来那个哎，博杰，要么你用英文把我刚才说的要点吧，2、3句话也跟Maarten和 Jay 也说一下。
Yeah, I think that the large language models, it is really really exciting field because we need to know the psychology of the large language models to work with them. Because in the future, everyone will work with large language models, will work with AI to collaborate. And so it is very important to know the internals, the fundamentals of them. So this book is intended not only to the audience who learn AI or learn computer science, but is meant for the general public, because everyone needs to know that what's the boundary of these models, what it can do and what it cannot do in order to live in a better world with AI.
好的，那我们接下来进入下面一个问题啊，就是这个，哎，对，其实今天就是3位专家呀，其实也都准备了一些也讲的东西啊，然后我们下面就进入这么个环节，那我们就让这个从这开始吧， 是吧？让
So
Jay 来讲一讲，就是今天他其实也准备了一点东西，然后也跟大家讲讲，就是这本书，一个是通过这本书它大概什么风格，然后也讲讲 Transformer 啊，包括大模型有一些演化背后的设计理念啊。然后 Maarten 呢也制作了一个这个 slides，最后还有伯杰的内容。好，那我们就接下来就进入一个小的迷你这个演讲的环节，好吧？
So let's come to a session of mini presentation. First, welcome Jay.
Jay can share your
Can
green.
you share your screen?
Yeah, screen.
Yeah.
Yes, I can talk briefly about the transformers, I guess, if that's so. Let me share my screen here. And so we can look at, I'm just going to use a few of the visuals from chapter 3. And in the translation version, you'll find all of these sort of translated, but just to use the visuals to say, lots of people have used large language models now, and they know, lots of people understand a language model to be a text in and text out piece of software. You give it a prompt, you give it some piece of text, and it will output and generate a text output. One of the first ideas that somebody new to transformers would need to understand is that they create their output one token at a time, or they generate one word at a time. And so you can think of it as just this loop of creating one word each time. And each time it outputs a word, it adds that word back out to the input, and that new input with this additional token or word goes through the transformer for the next output. So these are some basic ideas. People who are advanced in the field sort of understand this, but it's just to build a little bit of comfort and confidence in people and how this works for the general public, because from that we can go deeper and deeper into, okay, what are the various components that make up this transformer? And then you can see that there are three major components that make up this neural network. There's a tokenizer. We'll go deeper into these. There's an entire chapter. Chapter 2 is on tokenizers and embeddings, and it explains this. And then there's a stack of transformer blocks. This is where the vast majority of the computing and the intelligence is. And then at the end, there's what's called a language modeling head, which helps the model pick the token or the output of this computation. So this is, let's say, a beginning, a brief interview. And Boji, feel free to sort of cut me in if you need to translate any of this or to raise any questions.
I don't think we need to translate it. Yeah, please go ahead.
So in chapter 2, we talk about tokenization, which is to say that the model knows a specific set of words or tokens. So different words are broken down into subword components, for example. So if you download a open source model now, maybe it has a vocabulary of 50,000 tokens or 100,000 tokens. So that is a part that is sort of defined in the training process of the model. And with these, for example, 50,000 tokens that the tokenizer recognizes, there are 50,000 token embeddings that are stored in the model itself. And this is, when you hear that a model is 100 billion parameters, for example, or DeepSeek R1 or DeepSeek V3 are like 700 or 600 billion parameters. One component of these parameters is these token embeddings, is these vectors that represent the embeddings, and they're part of the first section of processing that a language model sort of goes through. After the processing, so we're still now taking a high-level overview of what's happening, and then we go a little bit into detail. And this is a little bit of a demo of the visual style of the book. We'll give you the high-level overview, we'll give you the main idea, the big idea, and then we'll go a little deeper and give you a little bit more of the detail after you understand the full picture. And so here, the full picture in the end is after the stack of transformer blocks and where the most of the processing happens, the language modeling head gives a score, a probability score to every one of the 50,000 tokens that it knows. And the one with the highest probability is probably the best next token to come here. And we talked about how you can control this with things like temperature. These are things that as you apply language models, you'll need to change some of these parameters like temperature. And what temperature does is it changes these probabilities that we see on the screen. We go through some of the code and some of the code examples and different coding strategies. So we see a visual where the output tokens are ordered by the probability, and we can pick the top one always, and that is what temperature 0 means. So there's no probabilistic picking of other tokens that can happen here if temperature is 0, or it's what's called a greedy decoding. And it's good for a lot of use cases, but not for everything. If you need something maybe creative, or you're doing something where it's brainstorming, you might want to set temperature to higher values, for example. But if you have a use case where, for example, there's only one right answer, you're giving the model a piece of text and you want it to, let's say, to extract specific names from it. These are cases where models tend to do better if you give lower temperature, and this is the insight into sort of how that works. Now, the transformer blocks themselves work in this way, but one way to understand it is to say, okay, so we have this input prompt. It was broken down into tokens, and the tokenizers sort of broke it down. So now you have all of them flowing through the transformer and the transformer blocks in parallel. So you can think of each token having its own track of processing that flow through transformer block number 1, and then 2, and then 3, and all the way up down. And so that's what's called a forward pass for this neural network. And it happens into these layers. And this is why it's called deep learning. The depth is this number of layers. And with transformer models, we're talking about maybe 60 to 90 to over 100 transformer blocks. And each one of these transformer blocks is maybe a 5 level or 10 level deep neural network in itself. So this is a high-level view of the vectors. And a vector is a list of numbers. Basically, LLMs are calculators for language. They compute language, and that is how they are able to create the outputs that we see from them. And they do that by operating on lists of numbers. So each word is represented by this vector, this numeric representation of, let's say, 1,000 or 5,000 numbers that capture the meaning of this word somehow, and it enables the transformer to continue the calculations on these vectors, and that creates these incredible outputs that we see from the models. When we're talking about GPT models, so text generation LLMs, one of the most interesting things that happen is in the final track, because that track, the output of processing the final token, is what produces the next token in the stream. And it is informed by everything that happens before it as well. So lots of information from previous tokens are pulled into this position. But the output of that final one is the one that is sort of produced as the output. And then when we're processing the next token, so we had our first flow through the transformer, and then we outputted the first token, and then now we're going in the loop and doing it again because we need to generate the second token. For efficiency, one of the biggest developments in transformers since the initial launch of the transformers are things like caching. So that make these models faster, so we don't need to recalculate everything all over again. And so there are lots of work on let's say, efficiency of how to make these models faster and enable them to generate text faster. And caching is one of these concepts. And this is a look at how that sort of works. Now we have a simple example here of how the processing works. So we said there are vector representations in the beginning. So we have our tokens, and then we replace the tokens, or we get the embedding of each of these tokens in the first part of flowing through the transformer. And that is passed to transformer block number 1, which does a bunch of calculation and processing on it. We'll go over the nature of that in a bit. But then it outputs vectors by the same size along each track. And then these go to the second block, and then it processes them, and it generates its own output. And each transformer block feeds a stack or a list of vectors to the next one. And that's how the processing flows through this giant artificial neural network. Inside the transformer block are 2 main components. There's a self-attention layer, and that is really the biggest maybe thing that the transformer architecture brought forth. It's called Attention is All You Need. So the paper that introduced the transformer is called Attention is All You Need, and it refers to this part of the model, doing something called self-attention. And then the second part is the feed-forward neural network, or the multi-level perceptron, multi-layered perceptron. We can think of these 2 components in 2 different ways. So a feed-forward neural network can understand or can encode the statistical relationships between tokens. And so if you have a common phrase, so here I use this film called The Shawshank Redemption, for example. The word Shawshank is not very common in the English language. So most times you come across it, it will be followed by the word redemption, because that's the famous film, a Hollywood film that speaks about this. And so if you only have the feed-forward neural network, if you don't have self-attention, this model would be able to predict that when it sees Shawshank, that the most likely next word or token to come after it is the word redemption, because that is in the training data, in the statistics of the training data. And that is what the feed-forward neural network does. And it stores lots of these statistical relationships between tokens. And so maybe the vast majority of what a model knows is stored in the various layers of feed-forward neural networks. And so that is one of the 2 major components of the transformer block. Let's look at the next one. So the next one is self-attention. And self-attention helps pull in relevant context from previous tokens, for example. So here we use an example that says, let's say we have our input prompt is the dog chased the squirrel because it, and it's not very clear what the word it means here. Does it refer to the dog, or does it refer to the squirrel? And it's maybe previous sentences in the prompt educate or can give us a sense of what that is. But that is basically what self-attention does. It enables the model, as it's processing its inputs, to pull in relevant information. So if it was referring to the squirrel, it will get some of the information from the squirrel representation in the embeddings and in the following layers, and it will bake it into the representation of the token it. And so that ability to better understand context and what different words refer to previously in the context is one of the most important things or advancements that the transformer brings together. And it's why everything we see with LLMs right now is possible. We don't have to go sort of too deep, but a high level look at what self-attention does is you can think of it as you have the current token that you're processing, and then maybe 3 or 4 tokens before it. And it basically pulls in the relevant information to this token that we're currently processing. And because GPT models are decoder models, these are text generation models, they operate in this way where they're what's called autoregressive. And so if you're in token number 5, you're processing it, you can only look at or attend to tokens from 1 to 4. You cannot look to future tokens. And so here is why we see sort of this look of or attention is presented this way of pulling in information from previous tokens. And the two ideas behind attention, one is relevance scoring. So one is the model or the neural network assigns scores to the previous tokens in the prompt to say, okay, which one is more important for us to pull in or get information from here? Which one is more relevant? Which parts of the prompt are more important? And here we simplify it by showing only 5 tokens. But this is the same thing if you give the model an entire piece of code and maybe a book as well. The model needs to pull in the relevant and important parts of the input. And this is what happens at each sort of self-attention layer. And then after it scores how relevant each token is, there's a second process of self-attention is combining all of that information into one vector representation and then passing that to the next layer. We go into, there's a little bit more advanced ideas about key and value and query matrices of how that interaction is actually calculated. We describe it with highly visual, say accessible way, and that helps us sort of explain recent improvements to transformer models that improved on this in the previous years after the transformer was launched. So we talked about efficiency. So there are many ideas for how to make self-attention a little bit more efficient. That includes sparse or local attention is one of these ideas, where some layers in the model are restricted to only be able to attend to a smaller set of previous tokens. And then there are these ideas of grouped query attention. These are also more efficient methods of doing this. And this is a high look of self-attention where we explained how attention happens in general, and then it happens in attention heads that represent the same thing, but they attend to different styles or different, let's say, parts, depending on how because they're initialized in different ways. And so they will tend to focus and pull in attention to different parts of the input. But the vanilla transformer attention head operates on the key and query and value matrices, which for now, we go deeper into them in the book, but for now, just to understand the high level overview, you can just think of each attention head having, let's say, 3 of these matrices. The more recent methods enable sharing of these, and so there's a smaller number of total vectors and smaller number of total calculations. That's what things like multi-query attention does, and group query attention does. And we've sort of come up with a visual language to sort of explain it, and you can get it through the book. And then we sort of end by showing that this is the initial figure from the transformer, from the illustrated transformer. And this is a 2025 or 2024 era transformer. They are pretty similar in a lot of ways, but there are some differences that happen there. There's a different ordering of where the normalization happens within the layer. The type of attention now is more toward things like grouped query attention. There's no longer positional encoding or positional embedding at the beginning. That has moved to things like rotary embeddings that happen at the self-attention layer, and then small differences in the type of normalization. I will stop here to sort of give a chance to, if there are any sort of questions we can take or areas we want to dive deeper into.
Thank you, Jay. 刚才Jay整个把这个 transformer 哈，其实比较简单的给大家讲了一下。我看也有评论说，这个如果没有技术背景还听不懂，是吧？我实际上跟大家讲一下，这个包括这本书你是不是能买？ 其实是可以的啊。为什么呢？你看刚才有一个人，有个同学在问这么个问题。就刚才这其实讲了很多 transformer 里头，它其实经常会说一个词儿叫 token， 是吧？包括我们现在其实用大模型，大家可能也慢慢也都知道，即使不是搞技术，也知道有 token 这么个词儿。因为 token 就有点像这个我们现在怎么像什么呢？像用电，是吧？我们只要用电就知道电是多少度的，是吧？我们接下来进入一个智能时代，就是要用多少智能，那个智能是用单位是用 token 来记的。然后就有一个同学问，为什么大模型都用 token 而不是用那个计算机？我们知道有什么 ASCII 字符啊什么的，是吧？为什么？或者说不是我们老百姓都知道的，为什么不用那一个字一个字？对，我大概跟大家说一下啊，刚才其实这也讲到了一些。你看我不是搞技术的，但是你看这个书，或者说你真正要理解，其实还是能理解明白的。因为大模型呢，很像人，所以它很多行为啊，其实是我们普通人可以理解的。但是具体有很多技术细节，你不搞技术可以不去理解它，但是大的概念是能理解的。token 是什么意思呢？为什么要用 token 呢？是因为大模型它是像人一样去理解。比如这一句话，就像我们这个图解大模型这5个字，是吧？你要用 ASCII 代码的话，就是每个图也是一个那个字符，解也是个字符，什么是吧？大也是一个字符，它就丧失了语义。因为图解大模型其实要处理什么？应该放在一起处理，因为我们知道这是一本书名，对吧？或者一本文章名。如果我们是一本书名的话，这5个词就应该放在一起，它就应该用一个 token 来代表。对，大家理解这个意思吧？所以它这个 token 跟 ASCII 代码或者什么字最大的不同是它有语义信息，就是那个意思你要考虑进来，所以它那个分析就不一样了，对吧？比如说Jay Alammar，是吧？这么一个名字，其实我们应该把Jay Alammar可能全部放在一起，对吧？当然这个事情呢也不是绝对的，为什么不是绝对呢？比如说如果 Alammar 是一个非常常见的姓，比如像我姓刘，李伯杰姓李，是吧？也许李和刘也要考虑是不是你是不是应该这个姓单独搞一个？其实这不是绝对的，知道吗？因为你这个姓如果把李伯杰整个的放在一起的话，这个转成 token 以后，它变成一个数字，那你去问李伯杰是不是姓李，他就可能就不知道了，大家理解吧？所以呢，李伯杰放在一起作为一个 token， 还是把李和伯杰分别分2个 token。这在不同场景下其实各有各的好处，也有利弊，大概也是因为这个原因啊。但是我不确认，就是之前这个就是经常不是有一个问题很好玩，就是 9.9 和 9.1 哪个大，是吧？之前就很多这个你拷问那个大模型产品，它当时就答错了，因为从原始上来看，大模型就是不好答对。为什么呢？9.9 和 9.1，大家想想要把它变成 token 怎么变？是吧？如果你把 9.9 整个变成 token 的话，它其实那个点儿后面那个1和9，它其实不知道你这个 token 里头还有一个小数点，或者说那个小数点呢还表示那个是有含义的，那个点儿后面一个是9，一个是1，是不一样的，对吧？所以很可能是因为 token 的这个原理，所以使得大模型其实，因为大模型 token 以后，它不是像我们一样看到字还是 Jay Alammar 或者是刘江或者李伯杰，它已经不是这样了，是吧？它看到就是一个数字，所以呢，这个数字如果它里头那个语义信息隔了一层的话，它就完全不知道原来那个样子是什么。对，所以大家理解的这个就是大模型其实跟我们人虽然很多方面很像，但是在处理的最基础的东西，其实跟我们人是不一样的。对，所以大家尝试理解这个东西啊，其实很多大的概念没有那么难。好，那我们接下来呀，请这个Maarten 来讲他准备的一个简的材料哈。当然，Maarten 也maybe you should present it a little shorter. Okay. Okay.
That's okay. Yes. Let me quickly share my screen here. So what I wanted to go in a little bit is some of the visual storytelling that Jay showed, because what we attempt to do is we try to make all of this, as simple as possible for as many people to gather an intuition. And for that, we created so many customized visuals for book like this, where we'll hear an example of tokenization where, and Jay mentioned it already before, we have to split up a given text into separate tokens. But the tokens actually have IDs, they have numbers that the language model can process. So a language model typically actually hasn't seen any text by itself, just the IDs that represent text. And it is these kinds of intuitions that we want to showcase and have people say, oh, but that's interesting. And we do that in all sorts of ways by showcasing all different types of visuals that help you get this intuitive understanding. Tokenization can be by word, by subword, by character, even bytes. And it's important to know these types of things because the field changes really fast and we've seen all types of tokenization techniques. And the same applies with embeddings, where we go through each step as clear as can be possible so that people have an intuition on how all of this works and how information goes through a language model. And there's a lot of thought behind these visuals because we can do something like this, where you can see different sentences being split up into tokens, eventually creating embeddings. But by creating a little bit more information there, by giving it a little bit more style here and there, it suddenly becomes more clear because we make sure that we give certain information, certain colors. So it's intuitive when going through a chapter. You saw Jay going through many visuals that all have the same style. And that was done on purpose to make sure it's easy to follow. Simple things like having rounded corners at certain points to showcase, okay, we're talking about an input. Or saying that the word tokens here is purple to emphasize, okay, it's a token embedding and everything that's about tokens after this will be purple. And a lighter tone to make sure the emphasis is on tokens. It's a little bit of this visual language that we attempted to create. And it goes for bird-like models, these representation models that we focus on, because we feel like this is a very important type of foundational model that's being used still to this day. And at the same time, of course, the GPT types of models, where Jay already went through, but having these types of visual language and showcasing how these transformer blocks work, how words are being generated, what embeddings are. All of this style that we've taken a lot of time to develop is within each and every single chapter. Because we feel like having this type of visuals, having this type of intuition makes everything just a blast to learn. It was always the case for me. I loved visuals. And so we created ourselves some sort of language, a visual type of language that allows us to communicate this as clearly as it can possibly be.
Thank you so much, Maarten, for your great introduction. Yeah, I think that the introduction of Jay and Maarten are very great. It introduced the concept of tokens and the transformers, the basic architecture of the transformer. Basically, Jay covered a lot about the illustrated transformer blog, the most famous blog read by millions of people, and it is enhanced and currently into a large chapter 3 of this book. I encourage everyone who is interested in large language models to read this chapter and at least have a basic understanding of how tokenization and how the embeddings and also how this kind of attention mechanism work. So it is if you have already understand all of this, you can know why the large language models has hallucinations. They make factual errors and they make computational errors. For example, the example that 3.9 is smaller than 3.11. Why it is often happening for the non-reasoning models. So yeah, this is very important.
对，我看到那个直播，包括我们群里有一些问题哈。We have some questions from the audience. The first one is what do you guys think of the 这个英文应该怎么讲的？那个伯杰那个就是所谓那个参数墙吧，是吧？撞墙了，就是说有点那个英文应该怎么说？
是说这个参数再多，然后的性能
对，就现在那个scaling law，对 scaling law 撞墙了，对。
The audience is asking about how do you think of the question of that diminishing return of the scaling law. For example, we have more parameters. For example, GPT 3.5, and we see diminishing returns of the intelligence of the models. So how do you think about that?
Scaling law
so
hit the
I
wall.
can take this.
What do you think about it?
So what we've seen, especially the last couple of years, is there's been a big attention on training compute, right? The more GPUs we throw at a problem, the more data that we throw at a problem, models will scale. They become more intelligent. But at some point, there's diminishing returns, obviously. We have scoured the entire internet. We have thrown as many GPUs as we could possibly do. And at some point, we felt like, okay, we have reached a limit. So scaling laws essentially state, okay, the limit is sort of reached. But that's for training specifically. But there's a new field that's becoming bigger and more interesting, or at least it gives us a new height of intelligence, and that's scaling inference compute. And what that means is that we essentially give the model to think longer before giving an answer. We've still trained a very large model, but now instead of saying the answer is 2, it will first think about and generate some tokens and information that it can use to then eventually come to a solution. So what we see, especially with DeepSeek-like models, is that they start reasoning. They give you a lot of ideas first. Maybe try this, maybe try that. What happens if I do this? What happens if I do that? And then based on the information the model itself generated, it uses that to come to the actual conclusion. And I have to say, as a psychologist, I like seeing this sort of change because it's what we are doing, right? If you ask me now a question, I'm going to sit here, think for a bit, get a little bit structure in my thoughts, and then I give an answer. And that's what the models are now slowly starting to do.
Yeah, Maarten has a very interesting point from psychologists, right? I think maybe we should learn more from people psychology, how to train a better model from human learning.
Yeah, it's in the name, but reinforcement learning from human feedback. All of the data that goes in a model, almost everything is by humans. And even if it was synthetically generated, originally it was all human information. And there's a reason we're trying to humanize these models, because they're trying to mimic what we have done. So it's not strange to think about these models from a psychological perspective, because everything the model learned from was from us.
Jay, you work in Cohere, I think the core circle, inside circle of the community. What do you think about what's the future of the large model?
We see.
How many the new milestones in the future, in the near future?
There are a number of different horizons where models can evolve and develop and have lots of different applications. I think to Boji's earlier point, or his current focus, agents are one very, very interesting route for the development of large language models, and getting models that are better able to solve bigger problems by breaking them down into smaller steps and tackling them one after the other, using tools, software tools, and otherwise. I think that's a very important development. And you can see this most clearly with software agents and software development agents, for example. But we also need to have that in other areas where to make people more productive in general. There are lots of interesting things in multimodality, in a lot of processing video and audio and images. So that I think this year, I think we'll probably be seeing lots of interesting developments in audio and getting more and more sort of natural sounding chatbots that sound very, let's say, human-like. I believe that's an area we'll see more and more of. And then, yeah, video coming up soon. So multimodality is one I'm excited about. And in Cohere, we're excited about multilinguality as well. So that every language out there has really good support in language models. Not everything has to be in English, even though I'm talking in English right now, but supporting lots of different languages that people can benefit from is another one. So I would say multimodality, multilinguality, and developments in agents and tool use are maybe 3 areas that I have my eyes closer on.
对，还有一个问题啊，那博杰可以帮我翻译一下，就是我看，他实际上是问的这个底层架构啊，因为刚才这个 Jay 和那个 Jay 也在讲这 transformer 是吧？就大模型，这个是不是有一些架构方面创新，比如 Mamba 呀，或者还有哪一些特别值得关注，可能以后就会取代 transformer 啊？不知道 Jay 和 Maarten 怎么看这个问题？ 包括博杰你自己也可以回答一下。
So Jay and Maarten, so what's your opinion on the non-transformer models emerging, similar to Rakul or the Mamba, so on and so forth? Will they just one day replace transformer?
Well, I'll leave it to Maarten because I think some of the best articles out there introducing the Mamba architecture are actually written by Maarten in his blog. So what do you think, Maarten?
Yeah, thank you. It's especially with this new sort of architectures that are being developed, there's a big problem, not with the architectures themselves, but there are kind of network effects happening when the transformers architecture came out. Everybody started using the transformers. And all of the new techniques that have been developed, all of the focus, essentially 99%, has been on making transformers more efficient. So even though you might find a new architecture that would be a little bit easier to train, that would be a little bit better to use, it doesn't benefit from the last 5 years of the entire world essentially focusing around transformers. And that makes it very difficult for these new architectures to actually break into this field because the standard of transformers is now so high. Every piece that was somehow a problem, we try to optimize it. And that same level, the same standard is now being sought for these new architectures. That said, they are very interesting. A big problem with transformer-like models is that they become more and more expensive the more tokens you generate and the more tokens you throw in it. But using models like Mamba that are focused on more recurrent neural networks, they don't care. Any new token that's being generated is just as costly as the one before. It doesn't stack. So I would love to see more and more of these different types of architectures that we can learn from and that evolve over time. I think one that was released recently that was very cool to see was a diffusion-based language model. And that's amazing because instead of generating text from left to right or right to left, it just starts generating text at seemingly random places, but it all comes down together. It all finds a way to merge together. And that's the same way that diffusion is handling images. It starts essentially from noise, right? And then it tries to find some sort of pattern in the data. That's amazing to see because language, if we're talking now about things, I don't think from left, right. It's a little bit more complex than that. I might sometimes think about the end of something that I want to say and then reason backwards. And that doesn't happen with an autoregressive model. There are many that say that autoregressive models they have a limit, and we shouldn't actually focus on them anymore because we know that they have a limit, and we should focus on something that can exceed this limit. So I would love exploring new technologies, and I think that's why it's also important not to focus on one thing in this field, but touch around different things. Because how cool is it to see diffusion, which is used in image generation, now suddenly appearing in text generation? So yeah, these techniques are just amazing to follow.
刚才 Maarten 讲的其实特别好，就是一点的话，就是说，比如说像 Mamba 这些模型呢，它其实呢解决了一个很大的记忆的问题，因为我们现在的这个 Transformer 模型，这个 context 就是上下文越长，然后它需要的这个计算资源就越多，然后导致说它很难去维持一个长期记忆，就是要维持长期记忆，它必须要依靠外部的 RAG 或者是总结这些系统。但是说呢 ，Mamba 这种架构，它因为是个循环神经网络，所以说它相当于是用一个固定大小的这样的一个状态，然后来保存的之前所有历史。所以说这个有可能呢，它就会成为一个未来很有趣的架构。另外，刚才 Maarten 也提到了一个非常有趣的一点，就是说基于 diffusion 呢是这种咱们现在生成图片的时候常用的这个模型。它生成图片的时候，它是从一个噪声开始，然后一点一点的去把这个图片里边的像素给它填上，然后让它从这个模糊的图像逐渐变成一个清晰的图像。那么说，对于文本来说的话，现在也有一些有趣的工作，让它能够生成的时候，它不是一个词一个词的逐个往后填，这个是我们叫做 auto-regressive， 就是说这种一个词一个词往后填的模型。但是它也可能是说先出第一个词，后边一个词。其实就这一点的话，我 personally 有一点就是想添加，就是最近有一篇 Anthropic 很有名的文章，叫做这个大语言模型的生物学。那它这个里边 on the biology of large language models。然后他这个里边呢就讲了说，我的这个 token 呢，其实呢有的时候他写诗的时候，他是先想的这个下一句话的最后一个词，他要先押韵，然后呢再去想它的第一个词。所以说，它可能我们能不能 fundamentally 从这个结构上让这个词从这个未来这个词不是说线性的一个一个出来，而是先把一个框子搭出来，再慢慢的往里头补词呢？这是有可能的。其实呢，从另外一个角度来看的话，我们现在的这个diffusion，这是一个方向，还有一个 auto-regressive 是另外一个方向，它中间是在合并的。因为其实现在即使是在图片生成、视频生成领域，其实也有好多公司，它也在做这种就是用auto-regressive，就是一个一个的去生成的这种方式来做。但是它的 auto-regressive 不是那个简单的一个一个像素生成，那太慢了，它是用另外一种方式。但是说，
是吧？
对。对，所以说这个视频啊，什么这个图片啊，它也在走 auto-regressive 路，所以说这真的是所有的方向，大家都有人去探索，非常有意思。
对这个问题呢，其实提的大家就也在说，这个大模型的往下，它是不是就固化啦？还是说，其实现在看来，其实还有非常多的这个方向可以搞哈。而且呢，大模型技术现在确实高度不稳定，还没有收敛但是恰恰是因为这个，才是我觉得对于搞技术的，或者说这个喜欢求知的人啊，其实是个黄金时代，其实老有东西可以学，对吧？不像有一些比较成熟的技术，几十年都没有什么新的，对吧？所以这是我们当然对我们出来讲也是个好事儿了，对于大家学习来讲，其实也是一个很好玩的意思。我看还有一个问题，当然是也是群里一个同学问的哈，他在说这个。看一下，那个群跑哪儿去了？对，有个同学问说，这个这又是个新问题，说程序员会被 AI 取代吗
So this is a very interesting question. Will AI ever replace programmers at all?
Because we know now it's very hot in Silicon Valley, the coding
Right?
products, right?
Coding agents.
Yeah, it's very hot.
It's we'll definitely see AI changing the nature of jobs, and this is something that happens with technology in general. It happens with software, it happens with tractors, and technology always sort of changes what jobs are out there. 200 years ago, most of people were working in agriculture, for example. And now only maybe 1 or 2% of people work in agriculture, because lots of that heavy lifting is now done by machines, by tractors, for example, and so on and so forth, and sort of across other ways. And so, yes, there's going to be an evolution in the nature of a programmer. The models are getting better and better at it. But then that also enables each programmer to be a super programmer as well and be able to have incredible tools that do amazing things. And so how can you identify the opportunity of that new power and then let's say apply it? So everybody definitely with the development of AI needs to take a look and develop their skill sets and adopt the latest tools and find the new opportunities for where that is taking the economy.
Yeah, I want to add some points from my side because I'm doing coding agents and other kind of AI agents. I use coding agents every day. For example, Cursor, Windsurf, and Tree from Python. These are very popular AI IDEs, and they will increase your productivity by 2 times or 4 times. I often have a concept of 4 times programmer at the time of now. For example, you have the 2 times productivity by handling this kind of simple refactoring or simple documentation, simple test cases, and simple kind of crude kind of codes that create updates, these kind of simple database operations or API operations to the offload entirely to this coding agents, hands-off coding agents like Cloud Code and also like Devin, these kind of things. And you have two times more productivity for this even harder and more complicated tasks. For example, you need to really enter your IDE to write the code. You cannot do that autonomously by a fully autonomous coding agent, but you can also leverage Cursor to use the composer agent or use the Windsurf agent to help you to organize the initial draft of the code, and you review the code and make some modifications, maybe debugging with the AI and let the AI debug for you to deliver the final product. I think feel that if you have good documentation and good kind of this test cases and test environment that is suitable for the agent to run, you will have 4 times productivity. So you will be a super programmer, as Jay has already said.
时间差不多啊。刚才有个同学说这个问了一个问题啊，说大模型有没有情绪识别能力？因为他是做这个想做心理学方面智能体啊。这个问题看伯杰。包括他说是不是要用那个私域布局去训练大模型，而且现在成本比较高啊，有什么建议啊？这么个问题，要不伯杰你回答吧，因为我们时间比较紧。
The audience question is that how we can make the large language models understand emotions, and do we need to make a language model that understand the psychology? Yeah, maybe Maarten is a psychologist. Yeah, but by my own point of view, we can just use the SOTA kind of large language models because it's smart enough to understand people's emotions. So you can try with SOTA language models, either the domestic Chinese models or the OpenAI or Anthropic models. They can understand your emotions quite well, and it can also do the role play. For example, if you have a characteristic setting, and if you, for example, to let it act as Donald Trump, so it will everything it says will be very similar to Donald Trump. So the current SOTA language models already have these capabilities. But if we want to just build an application that is similar to a psychologist, so this will require a lot of more work. That is the agentic work. For example, you need to do React database. You need to put your knowledge into a knowledge base so that it knows the professional things, and you need to build a memory for the users. For example, you do not want to just forget everything when someone comes to you for a second time. So you need to have a long-term memory. So this is not capable by the current context of the language models. You need to do it yourself. And there are a lot of other things. For example, you need to deep research some on the web or on knowledge base or on online resources to make your responses more factual and more latest information, because the large language models has a knowledge cutoff. It only knows information before some time, and if you just ask the recent news, it will know nothing about that. But you cannot let the LLM do the hallucination themselves. You need to let them to check the facts on the web by using the two calls of the agents.
Yeah, it's a very interesting question, right? Using LLMs for emotions, and like what you mentioned, yes, they can identify and reason about basic emotions quite well. These models are extremely capable, and they're starting to become more and more capable in seeing these types of psychosocial interactions between peoples and emotions and things. And that's obviously because it's all human data, right? They have recognized at some point that people do not respond well if you swear at them, for example, whereas if you're being kind to them, they respond in kindness. And the interesting part about this is it has so many layers when it comes to emotional things. So if I would take an example I've been in practice before as a psychologist, emotions run very deep and very complex and become really, really difficult. And for that, I don't see LLMs at this point being able to be good enough to do the work that, for example, psychologists would do. But for the main reason is that even people find emotions very, very difficult. We're still trying to mimic people in a way, right? By giving them data that represents us. So basic emotions, it does incredibly well. And when you go deeper and deeper, it becomes really interesting, because then it also becomes a question of what exactly is an emotion. Are people actually able to identify emotions themselves well? So when you interact with an LLM, are you honest about what you're feeling, etc., etc.? I don't want to become too psychological here, because it's LLM focused, of course, but it's very interesting to see this mirror of human behavior. It's trying to mirror emotions, and it can do that quite well, whether it's emotions of people or role playing. It's very interesting to see. But when it comes to something fundamental that really makes us human, that's tricky. That's a tricky part.
我也可以简单总结一下他刚才说的。
对，就是Maarten说的，就是说，虽然说呢，他能够很好的去理解这个人的基本情感，哎，就比如说你让他去做一个情感分析，这是我们几十年前经常做的那个 NLP 的那个任务，他能做到。
Sentiment analysis，
哎，对 sentiment analysis， 估计您也做过。对，然后但是说呢，如果说是真的是像他作为一个心理学家一样，能够去理解人类的这个深层的情感，然后分析它背后的原因，这个事儿呢，就是现在的 LLM 可能还做不到。
但是我觉得刚才这个读者他去问的问题就是说情绪识别，其实现在的情绪呢，现在大模型能力比原来的 AI 系统其实强很多了，对吧？因为它能听懂人话，能说人话，所以你给它的这个数据啊什么，它其实能判断，还是有比较多的情绪这个识别能力的。但是呢，到底它能不能做，实际上你要结合你那个场景，对，要说具体场景，你那个情绪识别到底用来干啥？应该能干很多事情了，因为现在至少我知道，像智谱啊，包括还有一些企业国内的，它已经做了一些这个心理健康的这个产品，就针对孩子的这个，就是在学校里头，因为现在我们知道有很多很年轻的孩子，他其实心理就有一些问题，是吧？那学校他就需要有个系统来筛查，不然你全靠心理医生一个个问。那孩子可能也不太愿意主动跟人去交流，他其实跟系统还行，所以这些系统已经开始在好多学校已经开始部署了，实际上是可用的啊。包括刚才你说那个成本太高问题啊，其实现在也有很好解决方案，就是说你先用这个，现在很多大模型公司是吧，都有这个 API， 你先用这个 API 用 token 去解决啊，先可以不用去自己去部署。因为确实，你即使 DeepSeek 像这种开源的，你要自己部署，你要买那个 GPU 是吧？你还建那个算力，然后你还要找技术人员，其实对于小企业来讲，那成本就高得不得了。所以先调用 API 就可以。包括你如果自己想看看你那个场景是不是能用，你实际上直接在这个 DeepSeek 啊、豆包、Kimi 啊，包括像我们智谱青年啊，就这种App 里头，你自己先直接试一试。对吧？你直接跟他就通过聊天界面试一试，这个大模型能力行不行，够不够你用啊？其实就有感觉了啊。所以大模型这个很好玩的一个时代呢，就是说，其实某种意义上人是平等的，对吧？就是你都可以跟这个大模型去试去聊天啊。其实从这一点上没有门槛，因为甚至可能最先进的模型可能还优先在 C 端产品会先上线，因为现在 C 端竞争很激烈 对吧？然后呢，你如果有技术人员呢，他就通过 API 去调用，也挺好。哎，我们时间差不多了，我最后再问一个问题啊，然后我们就可能要下线了，所以大家要趁今天拍这个书的啊，我们就抓紧。回头当然有机会，也许我们请 Jay 啊，那个 Maarten 啊，还能给我们做一些签名，是吧？那就更那好。最后一个什么问题呢？刚才还有一个同学问，就是说，各位专家怎么看这个大模型现在？因为大模型现在有很多优点，但是也有很多不足，是吧？就接下来大家从专业角度来讲，觉得哪些不足是可能，一个是它能解决，就是很快能解决，而且呢，它解决起来价值又很高啊。这个其实我相信这个问题背后是想什么呢？因为大模型的变化很快，如果我要做这个研发或者什么的，是哪些可能是马上就会变的，我就要为这个未来做好准备，所以是这么一个问题啊。
So the question is that large language models has many pros and cons. It has many drawbacks. So do you think which kind of drawbacks are going to be resolved very soon, so that when we build the application, we can prepare for the resolution of the evolved large language models, and which ones are going to be resolved very late, or even several years later, it does not have any progress?
Yeah, it's a difficult question. It's a lot of the times it's hard to tell. But
in the near future, I think maybe 1 year, half a year.
So the
What's
surprising
the next big thing upcoming?
Yeah. So interesting things are around reasoning. I think that was maybe one of the biggest things in the last 6 months. And then we're seeing people being able to, or companies and creators of LLMs being able to control the reasoning better and to give, let's say, budgets of how much should the model reason. Should it think too long or too low? But we still we need to better controls over that, of how much inference compute do we use to tackle sort of a specific problem. So better controls over reasoning, I guess, is one thing. We always need to consider safety and privacy and sort of these topics, and these are developing challenges. So when ChatGPT first came out, lots of people sort of thought of the language model as a search engine, which turned out to be a problem, because after people fall into or misuse the model, they start to understand that, okay, there's an issue called hallucinations, and so that's where we should build other kinds of systems like RAG systems. And so some of it is about how people understand the language and how we sort of deploy it and operate on it. And so finding better use cases for the models, and let's say controlling their behavior more around things like safety and responsible AI use, but also reasoning and how long should the model, for example, think or reason about this model. These are some, let's say, high-level reactions.
哎，好的，我们知道啊，李老师还有要跟大家分享的是吧？
哦，对，我忘了这个。哎，最后那个，对，伯杰其实准备了一点啊，其实这也是我们今天拍啊，其实我们有一个赠品，就是李伯杰老师自己专门从这个书里提了一些问题出来，是吧？然后给大家看，那个是有个小册子，是吧？如果大家拍了，其实是能附赠，其实就帮助大家在读这本书过程中，哎，更好的去学习啊，很好的一个赠品，哎，伯杰老师，你秀一下，对。
对，我刚才 share 了这个 screen，就是说我这里边专门从这个书里边针对它每一章的内容，然后呢，这个提了一些问题，就是因为我自己感觉啊，就是说好多这个大家就是在学这大模型，然后就是说或者说看一本书，然后不知道说是到底学会了没学会，可能看完了，然后最后还没有什么感觉，所以说我采用了一个新的方式，就是说这些问题，然后大家也可以自由从这个网站上面去下载，然后在书的那个记者区里边，然后我也有前60个问题。 然后可以去思考思考。这里边还是有挺多很有意思的问题。就比如说像这个第3章，就是那个 Illustration Transformer 里边这个最经典的这一章，对吧？然后这里边好多基础的问题，甚至是有好多搞过这个模型训练的人，他可能都不知道这些基本的概念，对吧？就比如说助力机制它怎么算的，然后为什么要除这个 softmax 要除这个东西，然后还有这个 QKV 的问题，对吧？就是 QKV 看起来 QK 一般来说都是对称的，但是为什么这个 KV cache 我们不说是 QKV cache， 而要说是 KV cache 呢？那 Q 跟它有什么区别？这个其实都是跟这个 Transformer 这个底层的架构非常相关的。其实如果说大家仔细听了刚才这一讲的那个东西，可能已经有一部分可以回答了。然后如果大家再仔细看了这本书，那这些问题肯定都可以回答啊。然后所以说然后等到后边这些这章节里边可能会有一些更难的一些问题，就比如说多模态模型怎么训，然后文本嵌入模型呀，还有包括表示模型生成模型，它就怎么去做 fine tuning， 然后以及 fine tuning 它的边界在哪，就是什么东西是 fine tuning 能解决的，什么东西 fine tuning 很难解决，比如说它是这个需要 pretraining 是吧？然后这些东西呢，其实让我们都会更好的一个理解，就是说什么时候我们拿到一个模型是用 prompt 的方式，还是用 reg 的方式，还是用这个 fine tuning 的方式，就是它各自能干什么，包括 fine tuning 也分 SFT 和 LHF， 现在我们都好多人都说 IL 对吧？但是 IL 其实也不是万能的。SFT、IL， 包括刚才说的这些经典的这些，像这个我们在第7章、第6章里边讲的这些 prompt 的方式，然后还有第8章里边这个 reg 的方式，其实都是非常关键的。所以说就是读了这本书以后，能够帮助大家更好的去理解这个大模型的每一种技术它们之间的关系，以及在最合适的场景下选用最合适的技术去解决。
Jay and Maarten, Boje had produced a set of review problems based book.
Amazing.
Yeah, and readers can download from our website.
Yeah,
Yeah.
Amazing. Great.
Prepare the interview through this book. So if you have ever read this book thoroughly and answer all the interview questions, all the 200 questions, I think you can enter any large language model company.
True. I get that a lot. So many people tell me that they've used this material and it helped them get their LLM job. And so I'm glad sort of, yeah, this can definitely help people.
Maybe we can translate into English and license back to already.
It's a good idea,
yeah. 所以当然这个伯杰这些问题呢，就是比较适合都是技术了啊，因为它其实是个面试，就是以后你要是搞大模型技术，这个要把这本书吃透，哎，借着这些问题你把它搞懂了。当然我们另外还有一本书是专门讲面试的啊，叫百面大模型。所以呢，大家以后就是往这个大模型上转我们其实提供了很多这方面的支持啊。刚才还有个同学问问什么，就是说这个大模型现在搞大模型的是不是有多少是转过来的？我就跟你这么讲，因为大模型非常的新，大部分人都是转的，对吧？就我在这个大模型公司工作，其实因为之前专门搞大模型就没有人嘛，就很少，对吧？你要算起来就是 OpenAI 最早，然后 OpenAI 出来的公司，包括国内就是跟智源研究院有关系的，反正有些合作的单位，就当时阿里有个团队和华为有个团队什么，就是那个人都是数以个位数计的，是吧？就是几个、几十个、就几百个，对。所以现在的以后的需求，大家各行各业全要干这事儿，所以需求无比巨大所以我也跟大家说，你无论是如果搞技术同学，你现在一定要开始学大模型，因为以后是吧？刚才有人问这个大模型确实对本身技术影响很大，对吧？就是很多简单的开发，它确实大模型自己就干了，所以你一定要往这边转一定要拥抱，然后再看你自己的实际上适合什么的。然后你如果不是搞技术的，也要往这边转，因为对人的影响非常的大。然后最后一个问题就是我们就结束了就问3位专家，就是我刚才讲的这个我自己先回答，就是我对于技术人员和这个非技术人员，就是面对大模型这个时代，大家应该做什么各位专家有什么建议？因为这个可能有 big change The question is， 伯杰帮我翻译一下。
So the question is, so what we need to prepare for the large change caused by the large language models.
I would say maybe understanding their fundamental operation and failure modes is an important thing. Adapting to new technology and using the new tools is important to see how they can improve your performance. So just like how Boji uses 3 or 4 different IDEs just to know how cursor is different from Windsurf, how it's different from other things like, I don't know, Cloud Code or example. So just adapting them in your everyday sort of life is useful, because you get the good of how well they improve your workflow, but also you get to understand where they fail and where you should not sort of rely on them for what kinds of use cases. And so for coding, we talked about these use cases, but I really love, for example, things like deep research. I find very useful. I do that quite often, this feature of deep research from the various sort of platforms, and a lot of the voice chatting with the apps. I think I've been, so being a first adopter of these technologies is always going to give you a good insight into how things will develop, either in your individual professional job and kind of capabilities, but also the industry as a whole.
And to add a little bit to that is, as Jay mentioned, we're kind of still at the early stages of LLMs, right? It's going really fast, and that's exciting and very cool. But like the early internet, things are changing quickly, drastically. The stuff that you're using today might not be used in a couple of weeks. And that's okay, because being an early adopter to all of these types of technologies will give you this benefit of knowing how to interact with these things and how they can be implemented. I think the world will look completely different in a couple of years, maybe even 1 year already, compared to how the LLM field is working today. It's still not integrated into every aspect of our life, but it's getting closer. And having very early interaction with these technologies will help you understand that it's not a magic solution, but incredibly beneficial in a lot of cool processes. And just using the hands-on approach, that will give you the benefit.
Yeah, Jay and Maarten has all talked about a very important word, that early adopter. I think early adopter of all the technologies, especially the large language models themselves, and also the products, is very important. Because I think many people have some opinions on what the models can do but cannot do, but many people do not refresh their thinkings over time. For example, many people still think that the models are kept as a time where GPT 3.5, that is ChatGPT, was initially introduced. It has a lot of hallucinations, cannot compute the numbers reliably, and cannot call the tools, cannot do something reliably. But this is no longer the case. Currently, the SOTA kind of agents and SOTA kind of language models, including our Pan AI, so for example, can do the phone calls to the customer services, can help you to negotiate a long bill. You can reduce thousands of dollars of pay through this single AI agent. So this is very fantastic. And also, Jay has talked about the OpenAI deep research. We also have the deep research, and also the computer use. Yeah, a lot of companies have released this computer use that helps people to use their computers through the AI agents to automate their daily tasks. So this is very exciting field, and a few weeks or even a few days, a new model is released and everything is changed. Something that you think it seems impossible in the past, it becomes possible in the future. And I think no one can imagine what the world will become in the 5 years. 5 years is too long for large language model. So what we do today is to be the early adopters about the models and about the AI products. So we can give the correct context and also the tools for the models. This is very important. If you ever build any AI applications, or if you just use the AI applications for the daily work, I think the context and the tools are very important, because the models itself is kind of a smart person. But if it does not have any access to your working documents, does not have access to your knowledge, and all your knowledge is inside the company, inside the people's brain. It is called tribal knowledge. Then the large language model cannot do something for you because it does not know the background of your task, what you are thinking. It cannot guess what you are thinking. So you need to make the context and tools available for the large language models. This is very important for us, for everyone to use them to boost our productivity.
对，我们抓紧时间哈，那个最后机会，然后大家可以把那个工学营拍一下。工学营就是刚才其实 Maarten 说的一个非常好的，就是 early adopter 这个概念啊。我跟大家说，其实我们现在经历的是个什么呢？是那个智能革命啊，就是有点像 industry revolution，the new industry revolution。但是我们现在是个什么时代呢？是像瓦特那些人还在改进那个蒸汽机的时代，对吧？大家为什么觉得这个大模型发展非常快？其实你看历史也是，就当时工业革命就是蒸汽机改进啊，当然它那个时间花的延迟很长，但是你要去看它改进了好多次，是吧？然后因为有蒸汽机，然后又有了这个纺织的这个机械，有的什么这个汽车呀、火车呀等等这些机械化。你会发现，你要按那个时间点，你发现哇，好多科学家、工程师就不断在发明创造。当然，他经历了可能几十年甚至上百年，这是上一次工业革命。但这一次呢，我们叫智能革命，是吧？工业革命是说，就是很多科学家和工程师造出了很多机械，实际上让人很多体力活不用人干了。以前只能是人加上那个牛啊、羊啊，是吧？牛啊、马来干，是吧？畜力来干。那现在智能革命是什么？就原来好多只能用人来干的，其实比较简单、重复性的这个智力劳动，接下来不用人干了。那在这个时间点，就是你越早进入，你越能看到机会，然后越能看清楚我们接下来自己怎么办，包括我们以后孩子怎么教育，是吧？这都非常重要。所以我们希望呢，是给大家是通过这个共学营的交流和我们的书，来帮助大家。来迎接这个新的时代，拥抱这个新的时代。然后技术人员，广大技术人员，你会发现大模型来了以后，其实对技术人员的冲击啊，比普通人还要大，对吧？所以这些都是我希望大家能够加入我们的这个整个这个社区啊，一起来努力的地方。然后呢，这个技术人员还有一个很重要的就是，你这个，因为大模型的技术跟原来很多还是很不一样啊，尤其你原来不是搞算法的。其实你想转过来啊，其实还是有一些门槛，有些难度的所以确实要把最好的书和跟着最好的专家一起来，这个非常重要。然后非技术的同学呢，就是刚才 Jay 讲的非常好啊，就是说你得首先把这个大模型的东西得用起来，是吧？你才有感觉。就像以后我们可能每个人都要带好多大模型 AI 的这个 agent 是吧？智能体一起干活，一起工作，一起学习。你首先得了解他是什么样的人，打引号的是吧？你才能当好他的领导。所以今天呢，非常感谢 Jay 啊，非常感谢 Maarten。Thanks for Jay and Maarten joining us to introduce the very insightful representation. Especially thanks Jay and Maarten bring a so beautiful book to us. 然后我们图灵呢也非常感谢这个伯杰哈，在创业的过程中是吧，还抽时间给我们大家做了很好的翻译啊，保证了我们这本书有非常专业的质量啊，非常优秀的这个图书质量和专业的内容啊，所以希望大家呢能够从这本书开始啊，然后呢加入我们图灵的这个圈子啊，以后接下来我们还出了很多好的书，然后有很多好的这样的直播啊。好，那我们今天就差不多到这儿结束了啊。以后我们下周还有一场直播，我们争取以后每周都有一场直播啊。然后我们也有很多的书不断的出版啊，能够帮助大家迎接和拥抱这个时代，好吧？好 ，it's time to end. Thank you, Jay. Thank you, Maarten.
Thank you so much.
谢谢伯杰。
Thank you so much.
Thank you, everybody.
Goodbye, everyone.